can figure out how to do that. It'll be my camera. It'll just be me, yeah. No, it won't be you guys. Well, I don't know how to get the camera up. So you guys online, are you okay with not seeing me? And can you hear me well? Thumbs up, perfect. Ooh, 3.
Can you hit the red thing that your name on the participant where it says red arrow?
This?
Oh,
That's the recording button. It's fine. Okay, so hello, everybody. Welcome to our second meeting. So today I'm going to do some super basic Python intro just for anybody who doesn't have any sort of Python background to give you some basis to base the rest of the semester off of. Feel free to stop me at any time. The people online, also my volume is all the way up. So if you talk, I'll be able to hear, and so will everyone else in the room. So that's totally cool. If you want to talk in the chat, I have that up on the screen as well. So I can see that and everybody else can. So don't tell me secrets, but you can talk in the chat if you want. So before we start, if anybody didn't get an email from me this morning, let me know. That means you're not on the email list. Okay. Shoot me an email or text me or something. And then, yeah, for the people online, if you can email me, I'll put my email address in here. So just send me an email if you didn't get an email from me this morning or yesterday, because that's how I was announcing this. And that's how I send out the Zoom stuff. So another question I have is it better if we start at 2:10 instead of 2? Because I realized that last semester we started at 2:10 and I messed it up and started to 2. So 2:10, we have thumbs up in person. Online, how do we feel about 2:10? 2:10 good? Okay, perfect. Yeah, so let's just change this time to be 2:10 from here on out, just to better accommodate people who have things till 2, which it seems like a lot of us do. This room is reserved for the rest of the semester, so this will be where our stuff is. Unless we grow too much, then we can move downstairs to the bigger room, but this should be good for now. The schedule is updated on the website, so if you have any questions about when you're going or anything like that, you can check on the website. It's the Sirio website. I think if you type in like WSU Python Working Group to Google, I think it comes up. Yeah, so I updated that. If I got anything incorrect, like if your names are wrong or like your topic's not exactly what you wanted, just let me know. It's also okay if you change your topic or anything like that. Nothing set in stone. We're just here to have fun. And then for people who are presenting, can you send me an email at some point so that I can have your email information so that I can send a document out to give you all more information about exactly what you need for your presentation. So this is my email again. I'll put it in the PowerPoint too, so it's bigger. So this is my email. Email me with questions and everything, or your email address. Okay, so does anyone have any questions or anything like that before we actually get into the Python? Woo, great. Okay, so we'll move on then. So I just started with some basic definitions for people who have no sort of concept of this. I wanted to give you some idea of what we're talking about. So a library is a family of like pre-written code. So that's something that you import and it gives you extra tools. And this will make more sense when we start coding, but just to give you some background. A variable is a value with a name assigned to it. That's just like we would think about in math or anything when you would think about a variable. A function is a named group of code, and so these you can write yourself, or this can be something that you are importing with a library. And then arguments are values or variables that are like given to a library or a function, or mostly a function, to sort of give it some more information about how to do its job or how to execute the code. And then IDE is another thing that you'll hear us talk about. And so that is the development environment, integrated development environment. And this helps just code more easily for a programmer. And we'll see some of that later on in the semester more so, but I'll use a little today too. So the first question you might have is, how do I get this working on my computer? So there are a few ways that you can do it. If you have it downloaded on your computer already, you don't need to modify it. It's all pretty much the same. But if you don't, there are a couple of options you have. You can download Python on its own and then work entirely through like the command line, or you can use an IDE, or I use Anaconda. And so Anaconda comes with Jupyter Notebook and Spider. And so these are two interfaces you can use to program, and I'll show you those in a second. This also comes with a library manager, so that helps you keep everything up to date, so you don't have to kind of do that on your own. So, yes. Yes.
Is there one way that would be easiest for a super beginner?
For a super beginner, I would recommend using Anaconda. And so if we click on Anaconda here, I'll bring it up. And so when you go to anaconda.com, it will bring you here, and then you can just hit get started. I believe Anaconda is an IDE. Does anybody know if that is completely accurate vocabulary? I think it is. Yeah, so Conda is a package manager, and Conda comes with Anaconda. And so Anaconda is like the overarching, like the big thing you download. And then within Anaconda, you get Conda, the package manager, and then you get like Jupyter Notebook and Spider. And so I'll show you those in a second. I'm going to stop sharing for just 1 sec so I can share my whole screen. Yeah, desktop one. Okay. So once you have Anaconda downloaded, you will have an icon that looks like this. This is your Anaconda navigator, or once you download it and open it. And so when you click on it, you will come up with something like this. And so this gives us a lot of different options. What I would recommend just starting with is Spider. You can also start with Jupyter Lab and Jupyter Notebooks. These are a little more complicated though. So I would recommend Spider, and that's what I'm going to be using today. So to start this, we can just hit launch. And sometimes it takes a while, and especially if it's your first time, it will probably take a little bit longer than other times. And this might not have worked for me because I already had one open. But this is what Spider will come up to look like. It won't necessarily be dark mode. I think I set mine up to be like this, but you'll get something like this when you open Spider. And so I just want to point out a few things before we start. Up here, I'll make the font bigger too before I start typing, but this area here is where we'll write our actual code. And then over here is where we can write code that's not necessarily saved within our script. So over here is like interacting with a terminal where nothing's saved. And over here is where we will program if we want something that we want to do repeatedly. So the kind of the name of the game is being able to do repeated science. So we want to be able to make these scripts so that they can be used repeatedly. Other people can repeat our work and can duplicate our results. So I'm going to start by typing down here in this console. And this is, we can tell that this is ready for Python because it has in, and then it has these square brackets. So That's how we know it's Python. And so I'm just gonna do some simple math here. So I'm gonna say 3 plus 5. And it gives us the solution. So it can do simple math, and it's bigger, this one too. So we can do whatever math we really want here. We can do 4 plus 6 times 2, and it'll give us our math. And so this is like great if you're doing some math at your desk, but this isn't super useful. So what we typically want to do is set things as variables. So I'm going to go over here to this code so that we can keep what I'm typing, and I can send it out to you all. I'm also working on posting it on the blog, but I don't know how to do that yet, but we're getting there. It'll be on the blog at some point. So this is how we'll define a variable. I'm going to define this variable called weight in kilograms, and I'm going to say 60. So I've typed this here and I hit enter, and it doesn't do anything because this is just like a text editor. This doesn't do anything. It doesn't run the Python until we actually hit the run button, which is up here. So if I hit this, it's going to run this whole file, and we see down here it ran the file, and nothing happened. And that's because we assigned this to a variable. If we click here to our variable explorer, we see that it's so small, but it's here. I can't make it bigger, but I promise you that that is the same variable that we just named here. And if we want to call that variable back, we can use weight, kilograms, hit enter in the console, we get 60. So this is stored in Python's memory. So there are a couple rules for defining variables. And this is a comment. So when you want to comment something out so that Python doesn't actually run it, you'll start it with this hashtag or the pound sign. So I'm just commenting this in the code because I will make this code available to you all after, and you'll be able to see what I was talking about. So a few of the rules we have are that they can include letters, digits, and underscores for defining variables. So we could do like weight kilograms, and that would be different than this other one. So it's also case sensitive. And lastly, we can't start with a number. So we couldn't say like one weight. We couldn't say something like that. That doesn't work. What is it?
One, I know that one is common.
Okay, yeah, so I'm gonna repeat your comments so the people online can hear that, and then I'll answer. So the question was, why am I using 2 hashtags here instead of 1? And there isn't really any reason in Python for me using that. I was just doing that to sort of differentiate between what is my like bulleted list versus my title, but it's all comment, yeah. Yeah, so in MATLAB, is that what you said? It's a different, yeah, it's like a $sign in MATLAB, right? Oh, percentage, okay, yeah. Yeah, so these are different in every language, but for Python, we use the pound symbol. So there are different types of variables and types of data that we can use. We can do what we call a floating point number. And I'm going to name this variable floating number. And so that's going to be a variable with a decimal point. So if I do 60.2, for example, that's a floating point number. And Python will always treat this as having a decimal. So if you want a floating point number, but you're using a round number, if you just do 0.0, it'll make it so that you're using a floating point instead of a non-floating point, which is a integer. It's a floating point is a number that has a decimal essentially. And then an integer doesn't. So that would be like 60. So another floating number could be 60.0, just it has that decimal point. That's what makes it that floating number. And then the last thing we can have are strings. And so to define a string, we have quotations around it. So if I wanted my number to be recognized as a string or like a letter, I can say this. And so now I'm going to run this by clicking this so we can look at what it looks like in the variable section. So I ran this and it went super fast because it's just assigning these numbers. But we can see up here that our floating point numbers are floats and they have those decimals. And then we have these two integers, both 60, and then our string is a different color and it's 20. So now we can do math with these variables now that we've defined them. So let's say we want to convert our weight to pounds. We can say weight underscore pound equals 2.2 multiplied by weight underscore kilogram. And I just realized that I don't have the chat up, so if anybody online said anything, I wouldn't be able to see it. Okay. Okay, so now that I have put this, we can run this whole script again. And it gives us this extra variable. And so we see that it did the math and the variable is 132. And so I'll just have it print this out. So if we want Python to print out a variable, we can just type print. So I'm just going to say print weight underscore kilogram. And then I just want to run this one line. So I'm going to do shift and enter. So if you hold down shift and hit enter, it will run the line that you're on. So this is the line I ran and I can run it again so we can see it. Get this chat out of the way. And so I ran it, which is what this line says, and then it printed out weight in kilograms. So I can combine a string and an integer here to say like the weight in kilograms is, and so this is a string because it's in single quotes. And then this is our weight in kilograms. And so if I run that again, we see that it prints out the weight in kilograms is, and then our variable. And so this can be useful if this weight in kilogram variable is something that's changing and you want to print it out often. So another thing we can do is we can check the types of things within our code. So to do this, we can just type and then type whatever we want to look at. So if we wanted to look at weight in kilograms, like we have been, we can type weight kilograms and then run that. And I ran the wrong thing. Oh, it's because I didn't print this out. You need to have print around it for it actually to print it out. So now we see that it printed out this print statement where we have the weight in kilograms is 60. And then we have this class int that we didn't have before. And that's because I'm printing the type of this. So I'm printing that this is an integer, which we saw up here. So I can do the same thing with others. I can print type and say I want to print my string number. That up there. And if I run again, we see it's added this line that says class string. So we know that this is also a string. So this is just another way to check these types that we see up here. And this can be helpful if you're not necessarily using Spider. You might want to print those things out just to check and make sure you're working in what you think you're working in. So a good way to think about variables, according to the lesson that I follow, is to think about it like a sticky note. So you weight kilogram is our sticky note, and our sticky note is holding 60. So it's like if I wrote 60 on a sticky note and stuck it somewhere, that's like saving it in the memory. And so the same goes for any type of variable. It just has to do with what's written on the sticky note. Okay, so I'm gonna pause for a second and see what questions we have, and if there's anything specific here that you want me to go over more, I can do that, or I'll move on to importing data.
Type on the left side, it seems to go really quick. It's like 1 minute, every second.
Oh, really? Huh. I don't know. It must be, it's just slow on your computer, I guess. The question was when she types in the left side, so over here, it's pretty slow. And so like the letters are slow in appearing when you're physically typing. Yeah, I think that it's probably has to do with the computer. I'm sorry. Does anybody have any experience with that? Any ideas? I type here. So I just was checking the different types of variables just so that it would print it out over here. So when I check the type of weight in kilograms, it gives me integer. And then the type of the variable string number gives me string. So these were to check those specific types. Does that make sense? So now just give me a minute or two so that I can pull up the next section on my iPad. I am not signed into the Wi-Fi, I guess. But then we will import some data.
Hey, Sarah, really quick.
Yeah.
Actually, is there, could you just show quickly how to potentially convert, say a character or string to an integer? Is that sometimes, or is this in the importing data? Because usually that's when it happens, probably.
I will go over it. Let me see if it's in my lesson at some point.
Okay, great.
Thanks for pointing that out. Connected to my phone's hotspot before the WSU Wi-Fi. Interesting. Oh, really? That makes sense. Yeah, so we will get to the converting of the types, if it's not today, it'll be next week. But we'll get there. Okay, so now let's talk a little bit about loading data into Python. So what I'm gonna load in is a CSV, and so this CSV is on my not my desktop, it is my downloads. And so here is my data. So you also have access to the data download, but it probably isn't worth your time to download it right now. Just follow along. So the first thing we need to do is import a library. And so we haven't done this yet. And to do so, we type import. And then we're going to type our library name. So the library we're going to import right now is NumPy. And so NumPy is a pretty common library that people use often to do like math type things or data import. I pretty much always import NumPy regardless of if I think I'm going to use it or not, because I always end up using it. So it's a good first one to look at. So to load a CSV, we're going to type NumPy and then a period and then load txt. And so what this means is from NumPy, we're grabbing load text. And then there are parentheses. And so this is where the arguments go. So from NumPy, we're going to take load text and we want to, fname is the what they call the file name within that. So fname equals, and then I'm going to put the path to my file. So I have that here, and if you have a Mac, there's a little secret where if you have it show your path down here, you can copy the path name. I don't know how to do that on Windows, but that's just a fun little Mac thing that I think is helpful. And then you can paste it in. And then I'm gonna make this a little smaller. And then delimiter, if I can spell delimiter right, equals, and I know that this has a comma in it, so I'm gonna put comma. But if you knew that your data set had periods or whatever, that's what you could put there. And so what is the default is, let's see. It definitely does. Thought that tab would tell me. Do I have to put, okay, here we go. None. I guess it assumes that it's space by default, maybe. Or maybe it just tries to be smart about it. We could try, let's see what it does. If we don't give it anything and we run that. So it says couldn't convert string to float. So it sees those, yeah, it sees the commas and it says, no, I can't, I don't know what to do with that. So it does need that. So delimiter, and then I'm just putting in that, the comma. And I'm just gonna enter down here. It's because it's indented, you can tell that it's the same command, but I just am doing that for readability. And then if we run this, we see it worked this time. We didn't get an error like we did here. So what? Yes, sort of. So what it does is it knows that the comma is what is dividing up the data. Yeah. So before it was thinking that this was just one big like data point. Yeah. And so now it's not in my oh, I didn't assign it to anything. That's why it's not my variables, but it did load it. So let's assign it to something. So I'm going to call it text file. And I'm just going to run that again so that it's saved in my memory. So now that I ran this and assigned it to a variable, so I assigned it to a sticky note, as they like to call it in the lesson, it's now saved up here. And so I can click on it, and these are the values inside it. So you see that every time there was a comma, it was smart enough to give it its own cell. And it is colored by value. But if you hate that, you can turn it off. But this helps you if there are strings or something in here, you'll be able to see the colors like drastically different. But that is the data within that file. How did I get the visual? I just clicked on it in the variable explorer up here. And it pulled that up. Is there a color bar for that? That's a good question. There should be. Maybe under format. Yeah. No, that's not. Maybe. I mean, so this output is part of the like, it's part of Spider, and so this isn't something that you really can give somebody else. Like you could, but it's not, this isn't really a product in itself. This is more of a way to just visualize it for yourself as you're using it. But I would guess that if you wanted to customize this, it would be in the Spider preferences. That's where I would guess you would customize this. It doesn't seem like there is a color bar, and I think that it probably just resizes to what the values are, unfortunately. Yeah, I have no problem with these colors. Okay. So what he said was that if there's a none option, then it just separates on any white space for the delimiter. Thank you for looking into that. So that's how we would load a text file. And so now we can do some stuff with it. So I think I'm gonna make a quick figure with it just to show you that, and then we can move, well, not necessarily move on, but I can take questions and we can be done for the day. I was wrong about the figures being in this section, but that's okay. All right, so to make a figure, we can import matplotlib. So the way that I do this is matplotlib or live. I don't really know how you pronounce it. I don't know how to pronounce many of these. And so I want to use pyplot, so I'm gonna say import matplotlib.pyplot, and then I'm gonna import it as PLT. So you don't necessarily need to use the .pyplot part, but if you look at the matplotlib documentation, it'll tell you those types of things. Like here it says import matplotlib.pyplot as PLT. So like that is evidently the common way to use this one, which I guess I knew, but so the documentation for the library will tell you like the most common way to use it. And there are a few basic libraries that you'll use in the beginning, like matplotlib will probably be the first plotting library, and then NumPy and stuff. But then as you Google things, you'll find other packages or libraries, and then you can read their documentation and kind of go down that path. Did you have a question too? I thought you were raising your hand. Okay. And then, so another thing about this is when we type as PLT, so this is just a shortcut and you don't have to do this, but this is the common shortcut for matplotlib.plt so that you don't have to type this every time you want to use it. like up here, how we typed in numpy dot load text. We're just gonna give this a nickname so that we don't have to type matplotlib dot pyplot dot whatever. And we could do the same for numpy, and people often do say import numpy as np. That's the general one for that. So you see that I have these exclamation points now, and these mean that I didn't use these packages. So it's telling me that I assigned this nickname and I didn't use it. So I'm just gonna delete it so it doesn't have an exclamation point. But so I have imported this plotting package. So now let's make a plot. So we'll do plt dot plot. And then I just want to plot the first line of our text file. I don't necessarily know what that represents, but we're going to plot it anyway. So I'm going to say text underscore file because that's our data. And then I just want the first row. So I'm going to do a square bracket and then a 0. And so Python counts from 0. And so this is going to give us the first one. And so I'll run that, and figure is now rendered to the plots pane. So then here's my figure. So this little line here gave us this figure of each value in the first line of our text file. And there are ways we can customize that, and we can get into that more if you're interested in getting into that more in future ones. But next time I'll go more into working with our data and doing kind of more fancy plotting things. So does anyone have any questions about the sort of basic crash course that we had now? I can give out more resources if anyone wants those.
I'm just curious, Sarah, if you wanted to plot the first column instead of the row, would you just add a comma, or is that not doable?
The way that I instinctively would do that is use a colon, comma, and then 0, because the colon means all. I don't 100% know if this is going to work out. We'll find out together. And it did. So that first line is all zeros. So the way that this is called indexing, and the way that you index in Python is you have your value, comma, your other value. And so here we had our, I guess this one would be rows, comma, columns, because we wanted just the first column.
Great.
Good question. Thank you. So someone asked what I recommend for managing libraries. And so in 2 weeks from now, that's the topic of my talk, library management. So I'll get into it more then, but for now, I guess I would just say, I don't know. I don't know what I would recommend for library management. I just try to install everything again at this point. And if it's installed, it will tell me. But for some background for everyone else, the way that you would install something with Conda is you would open your terminal window and you would type Conda install, and then like if we were installing NumPy, we would type Conda install NumPy. And so you all should have NumPy already. That comes with Python, I believe, but that's how you install. But yeah, so I will talk more about package management in a few weeks. Yeah, sorry that I don't have a better answer for that one. Well, if anybody doesn't have any more questions, then thanks everyone for coming. I hope this was helpful, and thank you. And yeah, next time I will kind of build off this. Oh, and I'll email this code out. And I'm gonna try and put it on the blog when I figure out that.
Thank you.
Yeah, thanks.
This is great. I've only used the Jupyter notebook, so I'm gonna have to try Spider. Thanks, Sarah.
Awesome. Yeah, I'm glad that this is helpful.